Welcome to our deep dive into the world of building management systems, or BMS. In this video, we'll focus on the crucial hardware and wiring that form the backbone of modern building automation. Whether you're a facility manager, engineer, or simply curious about smart buildings, understanding the hardware, especially DDC panels, will help you appreciate how buildings stay efficient, safe, and comfortable. Let's start by setting the stage for why BMS hardware matters and how it connects every sensor, actuator, and control point in a facility. Ready to unlock the secrets behind the scenes of intelligent buildings? Let's get started. At the heart of every BMS is the Direct Digital Control, or DDC, panel. But what exactly is a DDC panel? Think of it as the central hub that houses controllers, power supplies, communication devices, and wiring terminals. These panels connect all the field devices like sensors and actuators to the central BMS, enabling real-time monitoring and control. Proper design and installation of DDC panels are essential for system reliability and easy maintenance. In this scene, we'll break down the components inside a typical DDC panel and explain their roles in keeping your building running smoothly. Let's open up a DDC panel and see what's inside. You'll find microprocessor-based controllers that execute logic and control sequences, power supply units that step down voltage for safe operation, and relays or contactors for switching high-power loads like pumps and fans. Terminal blocks keep wiring organized, while circuit protection devices like MCBs and fuses ensure safety. Communication devices, such as routers or RS485 interfaces, enable data exchange with the BMS network. Cooling fans or vents help maintain optimal temperature inside the panel. Each component plays a vital role in the panel's operation and reliability. Not all DDC panels are created equal. Depending on the application, you'll find different types. AHU DDC panels control air handling units, managing fans, dampers, and temperature sensors. FCU or room panels handle zone control with thermostats and occupancy sensors. Chiller plant panels integrate chillers, pumps, and flow meters for centralized cooling. There are also lighting panels for circuit control and common utility panels for monitoring meters and exhaust fans. Each type is tailored to its specific function, ensuring efficient and targeted control throughout the building. Wiring is the lifeline of any DDC panel. Let's start with inputs. Analog inputs like temperature, humidity, and pressure sensors send variable signals, typically 010V or 420Mi, to the controller. Digital inputs, on the other hand, detect simple on/off states, such as flow switches or door contacts. Properly connecting and labeling these inputs ensures accurate data collection and reliable system response. In the next scene, we'll look at how outputs are wired to control building equipment. Now, let's talk about outputs. Analog outputs from the DDC controller modulate devices like valves or variable frequency drives, adjusting things like water flow or fan speed. Digital outputs typically trigger relays to start or stop equipment. Think fans, pumps, or lighting circuits. Ensuring correct wiring and separation of analog and digital outputs helps prevent interference and guarantees smooth operation. Together, these input and output connections form the nervous system of your building's automation. Good wiring practices are critical for reliability and safety. Inside the panel, use color-coded wires, red for 24V, blue for analog signals, black for ground. Label every wire and use ferrules for secure connections. Route cables neatly using troughs or ducts, and always separate power and signal wiring to reduce electrical interference. For field wiring, shielded cables are a must for analog signals, especially 420Ma loops. Proper grounding and adherence to protocol-specific cable lengths ensure robust communication and minimal signal loss. A well-organized panel layout makes maintenance and troubleshooting much easier. Typically, terminal blocks for field I, OS, are placed at the top row, making it easy to connect external devices. The middle row houses the DDC controller, relays, and power supply units, centralizing control and power distribution. At the bottom, you'll find MCBs, contactors, and surge protectors, providing circuit protection and safety. This structured approach not only looks professional but also enhances reliability and efficiency. Communication is the backbone of any BMS. For protocols like BACnet MS, TP, and Modbus RTU, use shielded twisted pair cables, supporting up to 32 devices over distances of 1,000–1,200 meters. For BACnet, IP, Cat5e or Cat6 Ethernet cables are standard, with network distance determined by switch design. Always terminate RS485 networks at both ends, set the correct baud rate, and use daisy chain topology for serial connections. Proper communication wiring ensures fast, reliable data exchange between controllers and the BMS server. Supplying clean, reliable power is vital for DDC panels. Most controllers and I/O modules operate on 24 VDC. Always isolate control circuits from power circuits to prevent interference and protect sensitive electronics. Use MCBs, fuses, and surge arresters to safeguard against overloads and surges. For mission-critical panels, provide battery backup with an uninterruptible power supply, UPS, to ensure continuous operation during power outages. These measures keep your BMS running smoothly and protect your investment. Before a DDC panel goes live, thorough testing and commissioning are essential. Start with continuity and insulation tests to verify wiring integrity. Use test software or jumper simulation to check every input and output point. Perform functional tests to ensure equipment starts, stops, and modulates as intended. Test communication links to the BMS server or head end. Finally, label and document all wiring and components for future reference. Proper commissioning minimizes downtime and ensures reliable operation from day one. Safety should always come first when working with DDC panels. Always de-energize the panel before opening it and use lockout, tagout, LOTO. Procedures during maintenance. Ensure proper earthing and bonding to prevent electrical hazards. Never overload relays or contactors, as this can lead to failures or fire risks. By following these safety guidelines, you protect both personnel and equipment, ensuring a safe and reliable building management system. To wrap up, DDC panels are the physical backbone of any BMS, enabling precise control and monitoring of building systems. Proper design, wiring, labeling, and commissioning are essential for reliable, maintainable operation. By following best practices and safety standards, you minimize downtime and maximize efficiency. Whether you're designing, installing, or maintaining a BMS, understanding DDC panels is key to unlocking the full potential of smart building technology. Thanks for joining us on this journey through BMS hardware and wiring.